Hi, welcome back. In this video we're going to create a dynamic spring. This would be a combination of part and assembly. Let's start with the part. Go ahead and choose the front plane. This one is going to be rather easy. I'm gonna use the 3-point arc. You can use any other method if you want to create half a circle. So once I did that, I am going to choose these 3 points plus this one and make them horizontal, and I am going to place the center of the circle on the origin. Very good. Now the radius should be 4 millimeters. You can go ahead and rebuild the sketch. Now click on the top plane. Draw a circle at one of your ends. Set the diameter 1 millimeter. Go ahead and reveal this one too. Now you can go to the Features tab, choose the swept bus, and create your part. Okay, before you carry on, go on the front plane, click on it once, and click on Show. We want it to be shown at all times. Very good. Now you can save this part under Spring or Dynamic Spring. Right? Good. Once you did that, you can go to File and click on Make Assembly from Part. You can just click OK for now. That's your first part, which is already fixed. Here, I cannot drag it. It's okay, I can have it fixed for the first time. Later on, I'm going to change it to float, but not now. Using the Control key, I'm going to duplicate this part, believe it or not, 134 times. That's the downside of creating a dynamic spring. So it would be done this way. First, I'm going to rotate this part like that, and very recommended to look at it in some sort of direct angle. Now you have something like this. Drag it a little bit closer because it's going to get a lot of space. From now on, I'm just going to hold the Control key down and keep dragging one of the above, one of the bottom, just like that, so I can have same number of both on each side. So for the sake of this video, I'm not gonna do it 134 times, but that's the number you will need for this Ikea desk lamp. I'm just gonna do it so many times. I don't know how many times I did it. Once you have that, you're gonna make them together. Just choose the edges and click OK and go to the next one. Repeat the procedure. I didn't place enough space between them. Now they're interacting. It's not a problem, but if you did it at first, they would have all had some distance in between. Again, it's not a problem. Almost finished. Okay, very good. Click OK. Now open one of these are all one part because we copied them. Open one of them and go on the front plane. It's supposed to be shown. You don't see it here. The reason is it's not activated. If you activate view planes from this menu here, or from the view, you can also choose planes, then you will see these front planes that you have activated. Just look at it at some angle, because from some angles it's difficult to differentiate them. Doesn't matter. And go to mate. Activate the multiple mate and also activate the parallel option. Now choose all the planes on this side. I click OK. Again, activate the parallel. Now choose all the ones on this side. Click OK and finish. You can just make the planes invisible again. Now if you just drag one of the parts, you will see it will move like a spring. So that's the whole concept of creating a dynamic spring. Now I have done this before with 134 times. That looks like this. You can just drag it and it moves. Now once you go ahead and connect the spring hook 1 and the spring hook 2 here and replace this part in your assembly, it will also move, but it would reduce the speed of your computer depending on the computing power you have by a lot, by a considerable amount of time. So if your computer can handle that, you can do this. You can replace this spring with the one that we used, the rigid one, and that would work. Let me try to demonstrate. Now that I have this saved, I don't have to save it anymore. I don't need that part because you saw it. Alright, let's just open our assembly. Alright, so this is the assembly that we created. Now I'm gonna go ahead and delete this part, which was a rigid spring. Now let's just do this one as well. Also these ones here. Now I'm going to open the dynamic spring and leave it here. Now I have deleted my rigid springs that we used earlier and inserted this dynamic spring. First, let's connect them to these hooks. Let me fix this part so I can drag the spring to the other side, because otherwise it's gonna move the part with it. So okay, now I can put it back to float again. Good. Now we can connect it to the other hook. Very good. Now we're going to define it as the dynamic spring that should be stretched or compressed. How you do it is, first you need to find your assembly, because it's a sub-assembly in your assembly. You need to find it here, which would be here. You don't have to open it. You need to right click on it and go to its component properties. Once you click on it, over here you will see an option, solve as rigid. You need to change that to flexible and click OK. As I told you, my computer does not have enough computing power to solve this assembly, but nevertheless I found a way to actually make it work, even though slow, but I can demonstrate. See, even if I hover my mouse over it, you get some graphic failures. The solution I found was, if I try to move the assembly from the spring hooks, meaning if I just click on the spring hooks and try to drag them or turn them around a little bit, then it would work. Then as you can see right now, I can move it like this, really slow, and that's only with one spring set. If I use 4 in the assembly, then the speed would be incredibly slow. But I think that will demonstrate that it's working right now. So let's just try it again. Yeah, really slow, but you get the point. If you use 4 of these springs springs, you need to be sure that your computer can handle that. I hope that you enjoyed this dynamic spring concept. Welcome back! In this video, we're going to assemble whatever we have created so far in the assembly section. For that, in order to speed up the process, we're going to open up all the files at once and take it from there. So let's just do it. I'm going to select them all and click on open. Alrighty then. Now we have all the parts open. So let's just go ahead and click on new and click on assembly. Either double click on that or be lazy and click on it once and click on OK, like me. You will then be directed to the assembly section. You will see all the documents you have opened on the left. We're going to start by choosing the base. If you click on it once, let me get rid of this. If you click on it once, it will appear at the end of your mouse and you can drag it around. So upon clicking anywhere, it will just get fixed over there. But we want it to be fixed at our origin point, at the origin point of the assembly section. So for that, we have two options. Either to go to View and activate Origins and click on it. Notice it pops up to the origin once my mouse goes, yep. Or in order to go through all that hassle, just simply click on this OK here and it will do the same. The next part we're going to insert is going to be the chassis. So let's just find it here, click on it and drag it here. From now on, I'm gonna explain to you what the assembly does. Assembly section in SolidWorks is basically about the relation between the parts in SolidWorks. So unlike many people who are going to send their files over or to their colleagues or to their teachers, they make the typical mistake of saving their assembly file and just send the assembly over. Assembly does not include the parts. It only contains the relation between the parts again. So if you want to send your assembly to someone, make sure to send all the parts you have used in order to make the assembly with it, or just save the assembly in another format, but in that way it's a different story. So having that said, we're going to define the relation between the parts. First would be the mate. This defines the relations and it's very intuitive. For example, you want to put this cylindrical shaft inside this one, so you either have to click on any cylindrical edge or circular edge for that matter on this part, and an edge or a circular surface on this one, and that would be it. It automatically recognizes that you're going to go for a concentric, which would be your option, either that or lock. Lock is always your option. We're going to cover that later on the base screw. So let's just go ahead and click OK. And what it does is it limits the part to move around other than going up and down and rotate around the axis that defines the concentric mate or relation between these two parts. So let's just go to the back, drag it down a little bit. You see this cavity here? We're going to make it tangential to this one. So we're going to click on this and click on this one. This one is a little bit counterintuitive for SolidWorks, so you're going to have to help it. Just choose the tangent option. It's very hard to see. It's a graphical mistake, but they're supposed to be tangential. So yeah, that's okay. After this, you're left with something like that. Your part can rotate, but it can neither go up nor down, or for that matter, left and right. So you can only rotate it. Let's just leave it somewhere here. Okay, next part we're going to insert would be the backbone. So just find it here and drag it here. Our backbone is going to be placed exactly in the middle of your chassis, and these two holes, or this one cylindrical hole, should be coaxial with this cylindrical hole. First thing first, we want to make it, put it in the center between the chassis. So for that, there is a perfectly adjusted mate you can use. You just go to mate and notice on default you're on standard mates. You have advanced and mechanical mates also. So click on advanced and I just noticed that because I clicked on this surface, this one is activated, so many options you see here are deactivated. Click on this, click on delete on your keyboard, so you're at the beginning of everything. Now you have all the options, right? We want to use width. What it does is to place a part in between two others, exactly in the center. The first two relations, it requires 4 references from you. The first 2 should belong to the first part, and the second 2 should belong to the second part. For the first one, we're using the green references, entities to mate. I'm going to choose this surface and the other one, and go ahead to the second one. Come back down to the chassis. You have different options. You can choose this one, choose this one, this one. What doesn't matter. I'm going to choose this, and this one. There you go. If you click OK, you will notice that now your backbone is exactly centered. Now, as I said, come back here. First, go to standard mates. We don't need advanced anymore. Click on this cylindrical hole. And click on the surface also. And click OK. So, see what happens. Yes, exactly. That would be the backbone. The next part we're going to insert would be the A-joints, and we need 2 of them. So, what would you do if you need 2 parts or 2 pieces of one part? Either you repeat the procedure like this, or you will be lazy like me and hold the control key down and drag that part. Let go of your mouse, left click first, and then let go of the control key. Now you have 2 of them, right? Very good. Okay, so these 2 A-joints are going to be placed on this side and the other side of the backbone. And for that, they have a perfectly round hole, which is going to be aligned with this cylindrical hole over here. Now, we have one common hole, which is going to be in relation with this and this. So we can either use the mate twice, or be lazy like me and activate the multi-mate mode here and choose our common reference and choose the other 2. Okay, let's just choose the first one. Before we click anything, we need to make sure that the hole, the larger hole here, would be placed on the bottom when we turn the parts 90 degrees to the left, which is in this case correct. If it's not, if it's for any reason is placed to the other side, before you click anything, click on flip mate alignment. What it does is it rotates it to the other way, right? But now I don't need it. You can either click it here or here. It does the same. You have alignment or anti-alignment, align. So let me just make sure. If I turn it, rotate it 90 degrees to the right along this axis here, which goes through this hole, the larger hole will be located on the bottom part. That's okay. So still, I don't click on OK. Don't get me wrong. I'm going to choose the next one first. Now, do the same for the next one. Would the same thing happen if I click OK? Would this be located on the bottom part? Yes, it would. So I'm going to click OK. Now, I don't need the multi-mode entity, so I'm going to deactivate it and go to the back. I go back to the normal section. Now I'm going to put the surface, make it coincident to the surface, this surface, to the surface, and I'm going to need these 2 to work together. They're going to have to work in parallel with each other. So activate the parallel option and choose these 2 surfaces and click OK and OK and OK and OK. Very, very good. Now we have the A-joints. The next part would be the M4X50. Let's just find it here, M4X50. There you go. We have it. This has to be located inside this one. You see what I'm doing? I'm just choosing or selecting a cylindrical surface and another cylindrical surface. And what it does, it immediately activates the concentric option. Nothing more. Click OK. Just pull it in a little bit. You see, you can move it through it. and I want it exactly in the middle. What I do is, again, what I did before, go to the advanced mode, activate the width, choose the first two references from your first part and the second two references from your second part, and bam, you have it in the middle. Very good. The next part or parts would be the leg, and we need two of them. Remember, what do we do if we need two of one part? Exactly. We drag it once, hold the control key down, and make it two. There you go. These two have to be symmetric. So we're going to have to rotate one of them 180 degrees. Preferably, I'm going to rotate this one. You find it under the Assembly tab, Move Component, but not on that, on the arrow, and Rotate Component. I'm going to just click on it, and click on it, and click on it. Oh, come on. Click. Are you kidding me? What's going on here? Yeah, finally. I'm going to rotate it. I'll leave it there. Alright, so this hole should be aligned with this hole, same here. And this hole should be aligned with this shaft, same here. Easy, right? Does it sound familiar? It's a multi-mode. But this time, I'm not going to do it. Not that you think it's the only option. It's just there to make your job easier, not make it more complicated. So I'm going to do it normally. I'm going to choose this one, and choose this one. Concentric appears. That's good. I'm going to choose this one, and again this one or this one, doesn't matter, and click OK. Before I carry on, I prefer to approximately locate them in the right place and repeat the same procedure. Mate, concentric. Oh, it doesn't do that. Oh yeah, oh come on. Because it's fixed now? Yeah, of course it is. Mate, and mate. Click OK. Same for this one. Mate. Alright. They have to be symmetric. They are not. We're going to repeat the same procedure with choose this surface and this surface. Then do it with the backbone. I just did the right click. No, it's okay. You see, they're symmetrical now. Click OK because we need some part here. Open up the bushing 5x for x 8. Oh, I said bushing and I'm just. There you go. That's the part. And I'm gonna need two of them. Mate, make them, yeah, concentric. That's good. And make them concentric with this hole. Very good. Drag one here. The distance between these two should be fixed at 10.5 millimeters. So I'm going to activate distance at 10.5. Now I'm going to choose my surface and second reference surface and click OK. Now you see the distance is 10.5 and it cannot be changed. They move together now. Now I want it exactly in the middle. What I do is I go to the advanced mode, click on width, choose these two surfaces and these two also, and click on OK. Very good. The next move would be to go back to the standard mode and click on the surface and make it coincident with this surface and click OK. It does it automatically. Very good. That's it. That should look okay. Yeah, exactly. No, that's my part. Finally. Next step would be to add the arms. We have two of them. not similar. I mean similar, but not exactly the same. But there you go. One of them has a hole in the middle, which is going to be placed on the bottom part, and the other one is supposed to be on the top part. So just go ahead to the mate first. We can use the width, but since the distance between these two is exactly the same as the width on the arm, we don't have to do it. We can just click on one of the surfaces and click on the inner surface of the A joint, and that does the job with the same effect. So for both of them, right? That's okay. I just click OK with the right click. Don't forget that. I'm gonna make this concentric with this shaft. Yes. And make this concentric with this hole. Yes. And these two should work in parallel with each other. So I'm gonna choose the top or bottom surface on each and click OK. So you see it here, right? They are always parallel. So far, so good. Now we're gonna add the B joints to the end. So go find them first. The B joints. How many of them do we need? 2. Right? Very good. For the sake of the argument, I'm gonna use the multi-mode mate again, because we're gonna have common reference here and 2 different ones there. That's the first one. And if that's the one, that should be it. But before I click OK, I notice they are aligned in the same direction. I need one of them to be the other way around. So now again, I'm going to use the bottom one, make it aligned, and now this one should be aligned. Click OK. That's very good. I'm going to drag one of them to the right side and deactivate the multi-mode, go back to normal, and select this one and the surface like this, and the other way around like this. You see what happened? The tighter part is connected to the upper arm, and the larger part is at your distal point. If you're not going to use it, I'm going to rotate it a little bit so you can see what happened here. That should be the B joint, right? That's your B joint. You can definitely move it around, and you're not interfering with any other mates that you have created by now. So just leave it anywhere there. That's good. The next part we're going to add would be the hanger core. So let's just find it under H, hanger core. There you go. Okay, good. Nothing has happened. It's just in the middle with the width. Mate. This and this should be concentric. Click OK. And rotate the part a little bit. This big curve should be at the distal point to the left, to the free side, and I'll leave it OK. Insert component, we need the hanger shell this time. Right here. This part with the small edge coming out of it should be on the inner side. So go on, click on mate. First, choose the inner surface and turn it again, put it on the surface. Look, not like this. I want it the other way around. So I'm going to click on flip alignment here, or just here, like this. That's okay. And also I want the top one to be on top of this. Click OK. Next would be, it has to also be in the middle, right? It shouldn't be playing. So go to advanced with, choose these two, and either these two or others, doesn't matter. Click OK. Now it's completely fixed and can rotate with the other one, and you cannot move it out, right? Very good. The next part we're going to insert, what is it, sir? It is the Y joints. You're right. 2 more points for you. Rotate component. First a little bit like, yeah. You don't have to, I just do it. I'm gonna make this one concentric for this hole and click OK. Choose this surface and this inner surface to connect them. Now let's look at it from interior. You have this, which can rotate 360 degrees without a stop, but this is meant to stop this. So how do we, oh no, how do we do that? We can do it in advanced mate with angle limit. If you set it at minus 144 minimum to 144 plus and click OK, you will notice if you turn it around, it will stop. What? Didn't I define it? Sometimes, oh, I don't know what happened. Let's just do it again. I click on this and advance this and this. Minus 144 to 144. Click OK. Now if you rotate it, see? You just adjusted it. Yeah. It does not pass that point. It gets stuck. Yeah. That's good. That's what you need. Next part would be the color. Color. There you go. First things first, we need to mate this circular surface with this circular surface, or this circular surface, or this circular edge, or this circular edge. Doesn't matter. They all have the same axis, so I'm going to click OK. And this one, this circular surface with this one, concentric, click OK. You see what happened? That's what I want. Next part would be the shell. The shell. I want this to go inside this, but the other way around, right? Here. Boom. Drag it. It shouldn't be like this, it should be fixed. So this surface should end up at this edge and click OK. Now it's fixed. Although it can rotate, you can see it here, right? If I rotate it, it can rotate, doesn't matter. Next part, that would be the bowl. Just saw it somewhere. Very big. Now let's just make it. This part should go on this part. Yes. And this surface should end up on this edge. Next part would be the adjustment shaft. You have it here. We're going to click on it. Cylindrical surface, very easy. Anti-alignment. You can drag it down even though the mate option is active. Now I'm going to choose. Now I'm going to choose the inner surface and click on this surface, so they would be tangential to each other, right? Look, it's tangential to this cylindrical surface. I'm going to click OK. That's very good. So far so good, right? That's the basis of the lamp. You can rotate it, you can adjust the side and angle, and you can turn it around. You can see that it's not rotating with the other one, right? So we can either lock them together or just fix this too. approximately because it doesn't matter really, but I'll just do it. Yep, I'm just gonna adjust this one with that one so they would work together. You're not gonna be able to see this, so let's just do it. Click on mate, the color, and the bow. Just lock them, right? And click OK. So now that you rotate them, they rotate with each other. Yeah. Like this. Good. Now all is left is just some shafts and bolts, which I'm sure you can do it, except for the springs. Follow me on the next chapter for the springs. Hi, welcome back. Let's continue with our assembly. Insert the spring hook 2. Select the surface and go to mates. We want to make it concentric with this surface on the chassis. See, concentric. Now click OK. I'm gonna drag it a little closer. This hook doesn't have a flat surface, so we cannot use width to make it centered. In order to make it center, I'm gonna go ahead and open its folder and click on its front plane. Click on mate and select midpoint on the chassis over here. You should be able to see a yellow square once you move your mouse over this edge. If you choose that, the front plane on the spring hook 2 and this midpoint will be joined together. Now insert the spring we have created. Looks like I have forgotten to open its file, so I'm gonna have to browse it here. That's a dynamic one. I need, for now, for this video, for this static one, so that's this here. Choose either end and make it coincident with the circular edge on the free end of your spring hook. Make sure the direction is right, otherwise just flip it. Very good. Now drag it up and approximately adjust its position. It's now time to add the axis shaft, the one that our spring hook 1 is going to be mounted on. That's M3X35. This should be located inside this hole, so they should be concentric, and also this end surface should be touching the end surface on the shaft. Insert the spring hook 1 and connect it to the free end of the spring. That's good. What we need to do next is to make our temporary axis visible either from here or from the view submenu and make them appear, because this is the only way we can mate the spring hook 1 on the shaft. Okay, make them disappear again. That's our first spring set. We need another set here, so I'm going to go ahead and duplicate the spring hook 2, and again going to mate this surface with this surface over here, but this time I'm going to flip the direction. The reason for that is spring hook is not symmetric, and if you don't flip the direction, your end result wouldn't be looking very symmetric. So just flip the first spring hook, either one or two, depending on which one you're going to do first, and the rest would follow. Again, choose the front plane, make it coincident with the midpoint on the chassis. Duplicate the spring now, and connect it to the spring hook over here. Make these two surfaces parallel. That should be like this. Now, I'm gonna drag the spring a little. It cannot be dragged. I don't know why. Let me check its mates. It shouldn't be the case. So I just deleted the mate to evaluate the situation. I'm gonna try to see if I can rotate the component, which I can. So it shouldn't have been the case. Let me just redo the process. I'm gonna mate it to the end of the hook, and it should be moving when I drag it. So duplicate the other hook, spring hook 1. I'm gonna try the dragging after I made this one. Put it here, flip the direction to adjust it. Again, the temporary axis, and mate them together. Before we carry on, make these two also parallel. Good. Let's try to move it a little bit. Okay, moved, but I also turned. Let me fix this and try to move it from the A joint. It also turns again. Okay, let's just fix the chassis for now so I can test the other part. Okay, that's good. It's moving. Even though the movement is limited due to the type of the spring, but it's moving. Let's carry on by inserting the M3X27. And mate it with the middle hole on the arm 2. And don't forget to use width to make it centered. Choose both ends and outer sides of the arm to make it centered. Now I'm going to duplicate it because I need another one on the proximal end of the arm. Again, I'm going to make it coincident here and click OK. The way I did it, I just hold the Alt key down and dragged it to that surface, so it recognized it that I want to do a mate. Now I'm gonna select these two surfaces because they need to be on the same plane, and since the upper one is centered using width, the lower one is going to adjust also in the middle, and I don't need to use width one more time. See, it's fixed. We need two bushings, 435 and 535. Duplicate each. First, the smaller one would go on the pin on the lower part. Make them concentric. And the bigger ones would go on the upper one. also concentric. Now all 4 bushings here should be connected directly to the outer surface of the arm. By that I mean for the upper ones it is obvious, but for the lower one, make sure not to choose the outer surface of the A-joint, but the arm. So the bushing would go through the hole on the A-joint. Very good. We need spring hook 1. So let's just go ahead and insert one. Spring hook 1 here. Again, using the temporary axis, I'm going to connect it to the shaft. And choosing these 2 surfaces, I'm going to make it tangential to the outer surface of the bushing. I'm going to duplicate it for later. And also I'm going to duplicate 1 spring because I need 2 more sets here on the arms. I don't need the axis at the moment, so okay, choose the last edge on the spring and mate it to the hook. We're gonna adjust its position approximately. What happened? All right, let's just settle here and adjust it carefully. Good. Now I'm gonna connect the other hook to the free end of the string. The axis, I cannot, oh, I have to rotate the part to see it. Very good. And click OK. We need another set on the right side, so I'm going to duplicate each part. And repeat the same procedure. The difference here with the previous set, the one that we did on the legs of the lamp, is that we're not going to flip the direction for the second set here. The reason being is that if we do that, we're going to limit the movement of the arm by a huge amount. So since it doesn't have a big function other than letting the arm to be able to move, I'm just gonna use the same direction and not flip it, and more or less use it as an optical object rather than a functional, because as I said, this spring is not functional. It is a static, rigid spring. It looks like a spring, but it's not. Don't forget to make these 2 surfaces also parallel. There is another video explaining the dynamic spring, the one that actually functions as a spring. You can watch that, and there everything should be normal. It's moving, so it's good. Now let's take care of all the shafts, bolts, and nuts, because all the main parts are here. Starting from the bottom, go ahead and insert M3X50. This should be placed in this hole right here. So I'm going to make it concentric as the first step. Next step would be to center it using the width option. Now I'm going to go and duplicate this bushing over here using the Control key and place it in the middle here. So first make it concentric, drag it somewhere in the middle, and we want to make it also stable in the middle. What I can do is just open its folder, click on its front plane, go to Mates, and from here open Chassis folder and select its front plane and make them coincident, like this. Now it's centered. Next step would be to insert, it's a stable, good, the hex nut. Here I have it saved under hex nut 2 due to various parts that I have saved, but it's the one that we made under hex nut. I'm going to rotate the part and also duplicate it because I need one on each end. So go to Mates, first make it concentric with the shaft, and also this one concentric, but we need to flip the direction here. Good. And make it coincident with the outer surface on the legs. I just used this line, but it also worked, so it's okay. Next, we need to insert M2X16, which is going to be mounted on the chassis. M2X16. Okay, it should be placed inside this hole. Using width, we're gonna make it centered. So let's just choose these four surfaces. Next, M3X20, which is to be inserted in the backbone and the chassis here. Like that. Once again, using width, make it centered. Now we need two bushings, 532. So I'm going to insert one and duplicate it. They need to be fixed on the M3X20 between the backbone and the chassis. Use the multiple mate option first to make them concentric on the shaft. Then use this surface to make them fixed on the backbone. Concentric. Now this should be fixed on the left side, the other one on the right side. Now we need two more hex nuts. So I'm just gonna duplicate it from here and here. First make it concentric. This one as well. Now I cannot use this surface because this is inclined and my hex nut is vertical, so I cannot choose these surfaces. What I can do is to choose one of the edges on the hex nut and choose this surface, because this surface, although inclined, but it's straight, so a line would fit on it. That would be okay. Again, doesn't matter which edge, but I'm going to choose an edge, and this surface and it would be fixed. I cannot turn it. See, I only have one solution for that. Let's just adjust the position. Another M3X20 shaft for the A-joint and the backbone. Duplicate it. No. Make it concentric. Here. And we need two more on the top, on the B joint. So I'm going to duplicate it twice and mate them inside these holes on the B joint. That's right. Now I'm going to activate the multiple mate. Choose one of the surfaces and click on this one and also the one on the bottom. So now they are at the same level. Once I make one of them centered using width, the other two would fit automatically, would be set. So let's just do that. Go to the advanced mate, activate width. Let's just do it for here. And the other two are now in the right position and cannot be moved. Yeah. Insert M4X50 now. Here we have it. Now I see the hole on my A joint, on the lower A joint, is 3 millimeters. So let's just fix it right here, right now. I'm going to click on it and activate sketch. I'm going to make this hole bigger. Draw a circle exactly 4 millimeters in diameter, or just place it on the edge of this hole, which is already 4, and go to the assembly section. Here you should be having an assembly feature button here and extruded cut. That's good. And I'm going to click all components. It's going to do the job. Now it's 4. Now I can make this M4X50 inside this hole. It also needs to be centered. So using width and the A joint, I'm going to center it. Now insert hex nut and the knurled screw cap. First, mate it on this M4 that we just inserted, flip the direction, click OK. And we need another one. So let me rotate this one first. So we take care of one side and then go to the other side. Click OK. And connect it to each other, to the A joint. Now I'm going to duplicate this part and rotate it. What happened here? I see some warning here. It means some mate is over defining the assembly, but I did not notice what I did. Let me check the situation. Let me just, okay, I just used Control Z button to go one step back and everything went back to normal. So I don't know what it was, but it's okay now. Make it concentric, and that's good. Now we need these two nerd screws in a symmetric situation, kind of centered situation with one another. So we're going to use with a joint. We can do that. That's good. Now they move always symmetric. If I move one, the other one moves too. I'm using the distance mate because the legs, the outer surface on the legs are not straight, so I cannot use it as a reference. And 37 was too much, so I'm gonna reduce it to maybe 28. Too much. Let's do 29. Now they're in a good position and on the shaft, so I'm gonna click OK. So that was the distance mate. Again, M4X30. We're gonna add another shaft here. Make it concentric with a B joint. Again, using the width, we're gonna make it centered. We need another set of nerd screws over here, so I'm gonna duplicate it 2 times. That's for the right part, and that's for the left part. Use multiple mate to make these two concentric. This time we don't need the distance mate because the surface on the B joint is straight and vertical. Therefore, we can use it as a reference to connect it to the screws or screw caps. Let's insert the ear caps next. You have plenty of reference to make it concentric and coincident with the Y joint. So take your pick and click OK. And we need another one on the other side. Next, I'm gonna insert the CB M3X10 and the hex nut 6X3X1, which are going to be set on the collar. First, make them concentric. One of the surfaces with one of the surfaces, that doesn't matter. And this surface with the inner surface should be coincident. Very good. Now, the bolt. I have to flip the direction. Very good. This surface should be coincident with this one. That's very good. Let's check if anything is missing. Yep, lots of stuff. For example, all the hex nuts, which are going to cover all the free ends on all the left shafts. So it means 2 more on this side, 1 more. Okay, on this one, I'm going to use the distance made again and set it at 1 millimeter and choose this surface and the other surface on the bushing to leave the spring hook in the middle. Again, 1 millimeter of distance, these 2 surfaces, and click OK. They don't need the distance, they can be directly mated together. So again, repeat this procedure for the right side for all of the shafts. I'm not gonna talk so you can enjoy the music meanwhile. Probably I'm gonna use some background music on this. So yeah. Or you probably wouldn't even watch this part because it's just a repetition of I don't know how many times. Don't forget to use the distance on this one and this one. But not now. Yeah. All right, let's do a checkup. See if all the bolts are there, all the nuts are there. Looks good. Everything looks all right. Yeah, it's functional. Let's just put it in the middle again. A little cooperation here. Yes, the arms are moving. You see, that's the downside of a rigid spring because optically it doesn't give you it's not the best result. Now one more thing, let me adjust the position on the bowl. I see that the Y joint is not rotating with it. So we have to do something about that. First, adjust the bowl, adjust its position approximately, like that's too much. Let's just pull it back. Yeah, that should be okay. Now we're going to use lock to lock the bowl with the color. Now if we click OK, the Y joint is connected to the bowl through the color, and you see, yeah, that's right. They should be like this. But you see, it's not stopping. You can do a full turn. It should not be the case. To fix that, I see we have no angle limit here. I haven't added. I haven't added it. So let's go to advanced mode and add angle. Do it from minus 145 to plus 145. Use this edge and this one and click OK. Now, if I'm not mistaken, you should now be able to go past that lock. Yep. You get stuck here, which is okay. It jumps to the other side. And you can do, yeah, that's right. Very good. I think we are finished with our assembly. Just turn the part. So that's your IKEA lamp disc. Congratulations, you just did it, and that's your functional lamp.